Okay, I should be live. I'm waiting for my feed to appear. Okay, and I'm still lagging. Okay, never mind. Like, this is going to happen. I'm not at my home right now. I'm at my grandparents' house. The net is slow here. So, yeah, I think that video quality is also going to be less than usual streams. But yeah, anyways, today I'm going to solve BP problems, obviously, but we'll see if time permits, if I solve enough DP problems, if I'm satisfied enough, I will be solving Code Chef's problems because I am able to solve like three problems within 15 minutes, and then the fourth problem takes most of the time. And then I won't even say very rarely. It was only once that I had solved like five problems in the contest. But yeah, or usually I solve around four problems. But yeah, but the first three problems I am able to solve within 15 minutes. So my goal is to solve these Q4, Q5, Q6 problems because they are interesting problems. I read them and I think like I can solve these problems, right? But I don't know. I it never gets accepted. I get a wrong answer or it fails some test cases. So yeah, hopefully I'll try to solve those problems as well. But first, let's solve more DP problems. And yeah, I will be sharing my screen. Ah, yeah, before that, I gave today's contest, weekly contest. I know I missed yesterday's bi-weekly contest, but yeah, today I did give weekly contest and I got a rank of 2022. I was able to solve three questions. This error like was a very silly mistake. Very silly mistake. Like I used int here instead of long. That's why I got a wrong answer. So yeah, and before writing the code, I had repeated this in my mind that yeah, the constraints are pretty high. You need to use long for this problem. You cannot use int. And then I did that, made that mistake. This let's open the question. See the question. Yeah, this was a pretty good question as well. Uh, it took me almost 50 minutes, around 40 minutes, you can say. But yeah, a good problem, a 6-pointer problem, but a doable problem for sure. Uh, this was a doable problem. Definitely difficult, not that easy to come up with. I mean, if you have practice these kind of questions, yeah, sure. But if you're a beginner, I don't think so. You will be able to come up with the solution because this is a very lengthy problem. Like, you had to handle this negative one case. You need to know what a pigeonhole principle is. Then, after figuring this out, you need to know all of this. Like, this is basic, this is simple. What is this? How is this even possible? And 30,000 people participated, out of which 1,000 have got 1,000 people. That's insane. Look at the timings. Look at the timings. Insane. This guy's first contest and he got first. Okay. Guardian in 8 contests. Contests. Okay. Dude, I need to improve on these problems. I need to get good. This is so bad. Okay. Anyways, and yeah, the Q4. I had the approach in mind. I did solve this problem using that approach. I mean, I tried, but I failed these two conditions. Yeah, anyways, we'll figure this problem sometime later. But before that, let's solve our problems, BP problems. For my BP problems, yeah, I am lagging very badly. Anyways, should I solve this problem? I mean, right now, or Hmm. You're given an array n string, all of same length. We may choose any deletion and we delete all the characters in the Create this and the deletion indices are 0, 2, 3, then the final array. After deletions is this. Suppose we choose a set of deletion indices such that after deletions the final array has its elements only minus the value of what does this even mean. Oh, this needs to be in lexicographical order, right? Yeah. Mm, mm. 0, 2, and 3. So VEF, VYZ. 'Return the minimum possible value of answer dot length'. We remove this. ABC is good. Answer value. Why is this problem a medium then? It is already in lexicographical order. XYZ CBA. What? How is CBA lexicographic order? Uh, Let's see Larry's video on this.
Uh, hey, everybody, this is Larry. This is me on a mountain 5,604 meters up. Hit the like button, hit the subscribe button. Look at Bolivia. And yeah, I'm going to catch my breath, and I'll see you soon. What do you think about today's poem? The Atacama. Hopefully you like the intro. It was very high and it was a very tough. It wasn't that tough of a hike, but I was just kind of I spent too long up there trying to get a good drone shot, so that kind of drained a lot of energy, or like 18,000 feet or something, which is like higher than Everest Base Camp. But 5 delete columns to make sorted too. You give it an array of n strings of all the same length. We may choose any deletion indexes, and we delete all the characters in those indexes in each string. Okay, I don't know what that means yet. And
I also didn't understand in the beginning what it meant, but yeah, I got it, but I'm confused in this example too.
you delete 0, 2, and 3. Okay. Suppose we choose a set of deletion indexes enter such that after deletion, the final array has the elements. Okay. So basically, we're trying to remove columns so that the strings are sorted. Is that the and we're trying to minimize the number of things to delete, which and I guess you can always just delete all of them, right? So that's like your base case. Um, hmm. mm, oh, and they actually show you here. Oh, I guess I should have looked at the constraints first. If n is 100, is that easier? Hmm. Um, I mean, I have two ideas that I'm thinking, right? Which I don't really have approved yet, just because I'm still kind of thinking through it. Um, one is that we just kind of try every column in some order, and then see if it is enough. Um, hmm. Well, I guess. Okay, I guess we should just try to kind of not necessarily like a strict proof, but just kind of work on thinking it through, right? For example, we have this thing, right? And on example one, and what that means is that well, the column one cannot exist, right? Because if column one exists, it doesn't matter what you do with the other columns, because if you don't delete column one, it will always be not graphic order, and then you kind of hmm. And I'm trying to think like whether my initial idea would have been like induction, but then do you always just delete it from the beginning? Because if they're tied, I guess if they're all sorted on that column, if the first column is sorted, then you just delete the next one. Is that the minimal? Versus hmm, I guess so, right?
Find the minimum possible value of answer dot length. Okay, so we delete this, and this. But why do we delete X, Y, and Z? Need to delete anything. Note that the rows of the lines and how is C, B, and A in the same order? Answer dot length. Suppose we choose a set of deletion indices. Answer. Set of deletion indices such that after deletion, the final array has its elements in the graphical order. Okay, so if the first column is in lexicographical order, then it doesn't matter, right? Whether or not the rest are in order or not. If first is not in lexicographical order, delete that and move ahead. We only delete from the start. This XWT not in order, delete it. Y V is not in order deleted. X you are not in order deleted. Just keep checking the first indexes after deletions. If at any point, but what if we can keep it equal, right? Yeah. If it's equal, then it's fine. But thank God for this condition, for this equal sign. Okay, we should be good. Int n equal to strs dot length. Now, in deletions for int I equal to 0 I, or should we just iterate over this string s equal to strs? Now, this can be of n squared, right? We can perform a of n square solution, so yeah, why not do that? Oh, oops. Int I equal to 0 I less than n I plus plus for this is the this is that character. This is no. This is the character. So this will be strs of 0 dot length, and this is we iterate over all those columns, all the strings strs, or let's just call this n j plus plus. Now if okay, if n equal to 1, return 0. What do we do here? strs of j minus 1 dot char at I should be less than equal to strs at j. This is the ideal condition. If this is true till the end, boolean in order, let's set it to true. Now if this is not in order, let's set in order to false, and then break as we move ahead. Then check we increment deletion here, right? If it's not in order. Otherwise in order, if this is true, return deletion. Just for safety, because it will not reach this condition, but if it does, return deletions. I think I can remove this condition as well. Oh wait, dot cash at I. I did work for this. This XXY. Yeah, this is a condition. What if is equal? What if it is equal? Then move on and check if we find the equal case, we go ahead and check this once again. This column once. We check this column once. We need to only check the columns which are equal ones. This row is not sorted. What?
I guess so. Because the idea that I'm thinking of, right, or the case that I'm thinking of, uh, is my computer slow? Is this actually recording? Can you actually hear me? Hmm, I hope so. Because otherwise, this is just gonna be very awkward. Um, yeah. What I mean is that, like, if you have a case like, okay, it's still not showing up on screen. Okay, there it is. Why are my computers so slow? I mean, my internet's just so slow as well. But you have like something like, let's just say you have, BBC, right? Like this is your first column. Let's just add an A in there. Well, because this column is sorted, if let's say you have a second but the entire answer is not sorted, right? Or the thing is not sorted. So if you have something like this, this NWY, that means that in this case, even if you remove the first column, the second column would still not be sorted. So
Yeah.
basically, we're just kind of keeping, and that's it, right? So we just kind of do it one at a time from left to right, and just seeing if it's sorted. That's pretty awkward, right? Is that right? I mean, it's fast enough because constraints are solved. I'm just trying to prove. This is a really tough proof for me. Maybe I don't know. I'm missing something, at least today, because clearly I solved it before. Is either that or I misunderstanding this one, which is also possible, I suppose. Uh, okay, yeah, I mean that's fine. Yeah, basically we just look at, we see the source, right? So maybe we have something like I mean I don't know. Usually, you should have a good idea before you start coding, of course. This, I mean, sometimes you just don't though. So we'll just play by thingy. Let me see if I can close some windows or something. Because something is this better? Testing. Okay. Um, I closed in a bunch of apps, which I mean is quite fair. Okay, so maybe we have something like wow true, oops, wow true, or like wow not sorted, right? So we have count is equal to 0. Hmm. I like. I don't know why I'm struggling. I mean, I'm not struggling with this one. It's just that like I don't know. I guess it is what it is, right? Uh, is graded. Okay. Hold on, wait. So then now you have like the columns, right? So these are removed, right? Um, so what I'm not sorted. So then this is now removed.
आज AI
Do you
Hello, everyone. Interesting problem of delete column to make sorted too. Yesterday we already saw its first part. That part was pretty simple, but this part, like it literally amazed me. What a amazing question! The thought process, the intuition. We'll see through it. We'll see the optimized solution also. We'll see a good solution which can pass. And with that note, let's get started with the video. Or you can say rate this problem 8 out of 10. It's a good problem, medium good problem 8. Or you can say according to the medium I would say 9 of 10. Overall the difficulty is 8 of 10 because the implementation is not that difficult, but the thought process amazing question. We'll see where you get stuck also, like okay, you can think that greedy idea and that won't work. We'll see the intuition why it fails. You're given an array of n strings str for all of same length. You may choose to delete some indices. Okay, means what it says, right? You can delete some columns. Okay, you can just delete one column or this column, entire column you can delete. For example, this if you delete 0 column, so a will be omitted, u will be omitted, right? So they are trying to say that it becomes lexicographically sorted. The complete array will become lexicographically sorted. What that means is lexicographically. I hope you remember that. Let's say A, B, that is different, and we have to check based on that. Let's say A, and then you can say B. That is very much of a concern. It is a concern, but it is not of much of a concern. We have to just solve and find device away. Right now, firstly, we try to understand one intuition that from where you should start deleting the columns. Okay, should you randomly delete some columns? Will it helpful or from starting it will help? Try to understand if it is lexicographically sorted. What does that mean? It means that this column will be sorted. This column will be sorted. Means like this first column will always be sorted. This, if it is sorted completely, then we don't care about much of this. What I am trying to say, let's say A, B, C. Now, there is also one more thing. This is the very easy case. Then if you have to find just the first index where this is completely, if there is some duplicates, right? There are some equalities. Now we are not sure about these columns. We're not sure about these columns, right? But we are sure about this column. But okay, this is sorted. There's no problem there. But this is a problem. That's why this problem becomes interesting. It's very interesting, right? Cool. We understood this thing also. Now what next, I am? So after seeing this, so what we have to do, we have to take some columns and we have to delete some columns and such that our it becomes lexicographically sorted. Some people can think of like a solution is like this. What you can do, same, you can just pick two strings and just compare the lexicographical thing. And wherever there is a mismatch, put into a set of indexes. What you can do, you can pick two string pair, let's say I plus 1, and then you can just pick these all kind of pairs which is possible. You maintain a set, and wherever the lexicographical condition breaks, right, we have to put inside a set. Until then, like let's say we have to comparing string A and string B, right? And what we're trying to say is, let's say we are going in this because both are of same line, no worry about that. Let's say here this is equals to same, no problem. If what we want eventually, we want B to be greater, like A to be less than equals to B. We want to make let's suppose at some indices A is greater, so we have to delete, we must delete that column, right? That is also perfectly fine. But till where we need to traverse, that is the question. Some people might think, Sayam, it is very simple. We go until we find an index where A is greater than B is greater than A. Till that indices, you keep on exploring until you find the first index where B is greater than A. Many people can say that, but this idea won't suffice. Why? Because it may happen. It may happen. Let's say I will show you an example. A, let's say B, and you can C, and Y, and A. Oh, sorry, A. Okay. Now what happens? Let's say Surprisingly, you delete this column. Firstly, you just compare on the basis of the first value, where these are lexicographically sorted. Then you will just compare. Oh, you will say, oh, there is no problem because B is smaller than C. This is lexicographically sorted, and ABY is smaller than ACA. There is no problem. But try to understand one thing, that what might happen is that if you delete this column, now is it correct? Now is it correct? No, it is not correct, right? You have to think like this. Okay, in this case, we cannot do these things, right? You're absolutely right about it. This idea won't suffice. Also, you cannot go until n also, right? You explore all the indices where this inequality is not satisfying. We cannot delete all the columns also, right? Let's say this is the condition. The same example I take ACA. Let's suppose we don't delete this column. We don't delete this column. So why we require this column to be this column to be deleted, right? We don't require that. So it depends whether this column deleted or not, right? So this might be an idea that might strike you, but don't go in that direction. This won't work. Okay. Now what you can think about. Now let's try to think of a very simple idea. Okay. Let's see, when you are not able to think and you are making multiple cases, right? Try to reverse your logic. It is our intuition that it might work. So instead of going in the direction that we are going like Sayam, we want to delete columns. Let's try to see what columns we can add and add as many columns as we can. That is a good idea, right? Add as many columns you can. No need to delete. No need to. You can add. Okay, that is our idea. Okay, Sayam. We will check whether our lexographical condition is satisfied or not. Light is gone, guys, but I hope you will. My face is not visible clearly, but stay tuned. Okay, lexographic condition should be satisfied. Oh, yes, Sayam. Now we can think of something. Now what we can do? We can add column by column. Okay, add column by column. And we can just check. Adding this column, will lexicographically condition will change or not? If it is satisfied, we'll add that column. Otherwise, we'll skip that column. Right? And from where we'll go? We'll go from left to right. We'll go from left to right. Right? We will go from left to right. Why? Why not from a random index? No, it's not a TP thing. Because we want as many as possible. So we'll go from left to right. That will help us create the solution better. Right? Left to right will go. And we'll keep on checking. Now, how we can check? It's very simple. What are you gonna do? You what you can maintain a complete new STR array. You can say you can maintain a cur and a pref. Initially, pref will be all empty strings of length of size n. Then n strings of empty strings. Right. We'll maintain this cur. We'll update this cur. We'll add the current column. Current column. And after this, what we gonna do is, if we add this current column, and if it is still lexicographically sorted, what is the meaning of lexicographically sorted? Means cur of 0 is you can check, you can just run a loop. You can just run a loop inside that whether our cur is satisfying the lexicographically property or not. Absolutely right, absolutely right. And then you can easily do that. And then good idea, it is better. It is optimal to take this column if it is satisfying the lexicographically.
2 and 3, right? So here 0, 2, 0, 2, 3, right? Here 0 is right, that right? Okay, this is example number 1, right? So I I have to do here one thing. First thing, just calculate the value of n. So total number of strings we have equal to. Can do one thing. I can compare this with this, right? Are sorted. Now here, if you see this, right? So what you need to do? You have to right now, right? This and this, and there is one pair of one total two pairs, right? So let's do one thing. Create one sorted boolean type array, right? And initially set both the values to false, right? Both these pairs to false, right? So this is having length, two elements are there, right? So I can say having length n minus 1, right? And its overall length and n minus 1, 2, right? So because 0 and 1, two values are here in the sorted boolean array. Clear? Right now everything is clear, right? As of now. Okay, now now here let's do one thing. Let's check over the columns, right? So here what we have here, if you see, we have strings like this: CA, then we have B and B, and then we have A and C, right? So this is nothing but, you can say, your column 0, right? So first let's discuss about this column 0. So in column 0 you have C, B and A, right? Now here if you see this, right, it's not sorted, right? So this pair is not sorted, both are false, right? But now I am going to check this character at this character, right? This character, tell me C is greater than this B, right? So it is true, right? So if this is true, then this is not valid actually. I need to delete it, right? Dictionary order means increasing order, right? So first A comes, then B type characters come, then C type words come, then D type, right? Like this. Okay, so here that's here deletion is required, right? So if here deletion is required, right? So here C is written to be break. I don't need to check this step further on, right? Let's go break it, right? Now here from here one thing is clear that we need to do some deletion, right? Need deletion. So let's create one variable deletions and increase is going to be this is static, right? One next character. So only 2 times I am running.
₹9. ₹9 cannot even buy you a cigarette, which kills you. But what if I tell you
Okay, so really appreciate it if you could subscribe. Now let's move on to combinations, another classic backtracking problem. We need to return all the possible combinations of k numbers in some range. This is extremely similar to the subsets problem. We just need to limit the subset size to exactly k, which means all we have to do is modify our base.
Okay, so to be honest, I kind of didn't have a plan for this video, but I was thinking, what topics could we address? And I mean, one of my favorite topics and one topic that a lot of people have questions about is the topic of backtracking and utilizing recursion to express a certain decision space or express a blueprint that blueprint tracking. Like, and I kind of want to read, actually address, I also did not have a mic, the quality wasn't the best, is choices. You have constraints restricted somehow. A decision space you can choose from. Your decisions are restricted somehow, and your goal is somewhere. Your goal is to do something. Maybe it's to fill a string, maybe it's to fill n slots. Maybe do is and like solving a Sudoku. Run through this. So what we need to do is description. Say that we do know how to start with it because we know the choices we're making. What we need to do is we need to fill these cells. We need to fill those cells, right? And we need to fill those cells by making choices. So
चला सगळ्यांनी जेवायचं आणि मला वाटलं हा बोलला की हा जेवून घेऊया 12:40 झाले ना. त्याला
Hey,
मला ती काय येऊ नकोस त्याचा डिस्टर्ब घेतो. चल ताटं काढा वाटी काढा चल. आई बाबा माझी. हे पाहिजे तुला चार्जिंग?
नको ते पाहिजे. थांब मी इथे लावतो ना फोन. थांब ते दे मग मला इथे. बंद कर.
आणि काय बोलतो हे असं डबल कामामध्ये सकाळी मीठ जास्त आता आधी
हो हे ते फेक नाही होत.
पण हे तिथे जातो.
हा पूर्ण आतमध्ये घाल पूर्ण आत. बंद कर त्याला बंद कर. पूर्ण आतमध्ये घाल खालचा. हा आता झालं. Is the partial bias on aspect of shape. You can either climb one or two steps or step to shape within this. Okay. No, this is a very easy problem. I mean, I am saying that, yeah, it is a easy problem.
everybody, this is Larry. This is day 9 of the July League Code Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Jump game 6. Okay, yeah. Hope everyone's having a good beginning of the weekend. Hope everyone's all right. The 2 contests tomorrow, at least for me, is tomorrow, but 2 contests in the weekend for Lead Code. So hope y'all enjoy. Hope y'all do well and all this good stuff. Anyway, let's get started on today's farm. Okay, so you're given neutral weight nums and you're starting at 0. One move to jump K4 without going outside the boundary. Okay. Yeah, okay, so you could jump K step 1. Okay. You want to reach the last index n minus 1. Your score is the sum of all nums of J for each. Okay, so. Okay. I mean, this is going to be dynamic programming, so. Actually, I think this is a good example that I want to demonstrate a little bit. Because I think. Not gonna lie, when I was younger, I think I struggled with this problem a bit, or not this specific problem, because this one is very basic in the way that they represent it, but more that they they disguise in some ways, and I'm thinking about the naive dynamic programming. I'm unable to make that additional optimization, but this one, it should be okay. So the key part, and I'm going to write this out brute force, or not brute force, sorry, but the more naive dynamic programming, and then we will kind of talk about it, right? And then kind of make the optimization. Of course, I think for today, this is Friday, so I'm going to make an assumption that people are familiar with dynamic programming. We've done 4 or 5 problems. If you do struggle with today's, and especially with this explanation, maybe go back the last couple of days and yeah, maybe go. Wait, why is it 0? The maximum score, is that actually just 0 or? That's weird.
Yeah. Because we should follow the improvements. Let's say do this. We want to reach the last index. Example, so the score is the sum of elements that each index is a The score is the sum of all values of j for each index j you visited in the mm,
Is that actually right? So from 2 to 4 to 7. Wait, oh, did I miss that? Okay, so maybe this is -4, this is 0, 3, okay, so maybe it is just 0. Okay. Yeah. 0, 3, okay, so maybe it is just 0. Okay. Yeah. Okay, so maybe I'm gonna. Alright, I'm just gonna write the naive solution. Okay, yeah. Let me say it one more time. So I was just checking the font to make sure I didn't miss anything dumb, and then have to redo it. Long-term viewers know that I sometimes do that from time to time. Okay, so yeah, so for these kind of problems, like I said, if you do struggle with dynamic programming, work on the past week, my videos are here. So check that out, and then maybe come back to this. But for now, I'm going to assume that we know, and the way that we write the naive, quote unquote, naive dynamic programming is like this, right? So we have like a DP array from, and here we have the max score, and we want it to be negative infinity because they're negative numbers, so it can get very bad. So, okay, so infinity is equal to 10, 20 is
बाहेर
it is
like to do because this is bigger than long as y because I'm not going to take before. So it's this times 20 is what I like to do because this is bigger than long as y because I'm not going to take before. So it's this times say n plus 1. Yeah, and n is equal to length of node. And then dp of 0 is equal to 0 because we're starting from 0. And then now here, dp of I is equal to, and this is just notation, sorry, maybe it's equal to the best score coming from 0. Actually, maybe I don't need it because you start at 0. So actually, maybe I want this to be the case. Okay, right? Coming 0 and ending at index I, right? That's basically the idea. And then here, the naive way you would do is for maybe for I is going to range from 1 to n, non-inclusive because just the indexes. And then now for j is in range of say from 1 to k plus 1 inclusively. Let me actually make sure. So k, what is that? K step 4, right? Okay. Yeah, I plus k. So yeah. And then here, you want to say that dp of I is equal to the min of dp of I, dp of I minus j. We probably need to add a if statement. Yeah, that's the best spot there, plus the current number, right? Is this right? Yeah, that's one step backward, and then 2, and then all the way to k step backward. So that's going to be our answer. I'm going to print out the dp, and then we're going to return the last cell because that's what it's asking for. Right? What's the max score you can get to? Oh, I won't min for some reason. The max, and here, right, that's right, max, right? And this should be okay, though maybe too slow, right? Yeah, so this is okay, and I just pointed out for reference. So that's the basic idea, and I think this is basically what you might think about it. In that, you know, if you don't understand this, I do recommend practicing dynamic programming. I think this one is a very standard or I don't know if it's standard. Maybe I wouldn't use that word, but it's something that you will get or expected to know in an interview. So like it is almost like prerequisite. So if you don't get this, you probably need to hone up on that skill to get it, right? At least this solution. And basically the solution is just, and I'm gonna bring out my my paint real quick. Let me draw some stuff on the screen for y'all. But basically this is almost like one of those things where, you know, you have a lot of cells, right? Yeah, this drawing stuff is hard. That's not even straight line. Sorry, let me just write a box here like this, right? Make sure that it shows up on screen, okay? So let's say you have all these indexes, right? And you have something like, you know, now, you know that the last place that you can jump from is here, and here the last place that you can jump from is here, and then here, right? And then here, let's say k is equal to 3, right? Then here you can look at, you know, 1, 2, 3, right? It's the last spot. Here it can be 1, 2, 3 as the last spot, and so forth, right? Dot, dot, dot. So that's basically the idea here is the dynamic programming, right? I mean, I know that would have made a little bit quickly, but the idea is now that we look at, okay, if I minus j is the last spot, what is, you know, let's get the best score that is at that spot, plus the score of landing it here, right? Okay? And then now the question is there another way to phrase it, right? Well, looking at this function, what do we see, right? Rewriting this very quickly, look at this very quickly, we now notice that we're basically, and as I'm doing symbol wrong. Oh, this is kind of, I would say this is maybe a little bit tricky for a medium one. But maybe not, maybe I did it a silly way. No, I think I'm okay. But yeah, maybe there's an easier way, but I want to explain the technique anyway. But yeah, looking at this formula, right, what do we notice? Well, let me actually write it on the paint again, because I think that's more better. Right. So we basically have this idea that we have some f of I is equal to some f of I minus j, for j is, you know, well, this is plus some a sub I minus j for, how do I say for? Whatever, I'm just going to write the word for. I forget what j's apple goes, I always forget. For j is in 1 dot 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 all the way to k, right? So that's basically the idea. And then once you see this formula, the thing to do is noticing that, oh, sorry, I messed up here. Hang on, this may make it confusing. This is not I minus j, this is a of I, right? Okay, now this is more clear, maybe, hopefully. Right, so now let's say we have this formula, right? And we want to optimize it. or think about rewriting it another way. Well, what can you do, right? Basically, you want to min this function. It's basically a of O is saying that. Oh, sorry, I messed up here. Hopefully, right. So now let's say we have this formula, right, and we want to optimize it, or think about rewriting it another way. Well, what can you do, right? Basically, you want to min this function. Is basically the idea. Or actually, sorry, max this function. Because I don't know why I keep saying min, but so you have this function, and you want to max this function over 1 minus k, right, or 1 to k. And then the idea here is that, well, this term does not change. So basically, you want to rewrite it to max from 1 dot k. This is a j. F of I minus j plus a sub I, right? Okay, I hope that this part makes sense. Right? So hopefully this part makes sense. And I'm going to rewrite this really quickly, right? So what do I mean by that? I mean that here, you know, like I said, I'm doing this for teaching purposes, so definitely I would have done it a little bit better in my head. But let's say I is equal to negative infinity, which it already does. Let's say the current best is equal to negative infinity. Maybe I don't need this quite yet. And then here, you may rewrite this as best is equal to min, or sorry, I keep saying min, dpi minus j plus num sub I, right? And then at the end, dpi is equal to best, right? So that's another way of writing it. Perfectly okay. Should be the same thing. I'm just wondering real quick because I have a typo, right? Yeah, so it looks good. And then what I was going to say is that, okay, now you realize that you can take out this term because it's going to be the same over the entire range. So then let's get it out and then put it here, right? Okay. And then now essentially what are you doing? What you're doing now is getting the max of the last k numbers. That's basically what we're doing. And so how do we optimize this, right? And the way to optimize this now is just by using something a little bit trickier, but still doable. The idea here is now, you know, well, the idea is going to be sliding windows. I'll just say that part out loud. And you can kind of visualize why that is, right? Because now, and okay, I'm going to go back to drawing. I keep on putting the drawing away, but maybe I want it back. Because now, instead of, let's say, this thing that we have on top, what we have instead is, let me erase this. So now, instead of this thing, well, let's say you're looking at this cell, right? What happens? Well, you want to take the min of here. Oh, sorry, the max. I said, I keep on saying min, but you get the idea. You're smart at home. You know what I mean. And then now, let's say we're looking at the next cell afterwards, right? What happens? How did that happen? I guess I am trying to figure out what happened. Oops. Right? And then here, let's say this arrow moved to the right, so now you have to here. What happens? Well, this range that we're looking at also shifts to the right. Same thing here, shifts to the right. Same thing here, shifts to the right, right? So I think now, there is, you know, like very naively, I mean, hopefully that visualization makes sense with the sliding window. And of course, there are some let's say there's some like log n example solutions, but we're going to be going over an O of n solution instead, or not O of one solution for an update instead, right? How do I do this? And I don't have it on, I have the idea, but we'll prove it together and we'll figure it out together. So I think the idea is just, yeah, and this is by itself going to be another medium problem. So definitely it's possible there, but yeah. Okay, so now as you can see, so why do we want to optimize? Let me go over that real quickly as well, because what is the complexity here, right? Well, this is going to be n, this is going to be k. We look at the constraints, n is equal to 10 to the 5th, k is 10 to the 5th, so this is going to be 10 to the 10, and that is no bueno. I mean, maybe, I know that you can actually, that's not a tight bound, you could do better, or on average it'll be much better, but you know, that's still going to be, even if it's 10 to the 9, it's going to be too slow, right? So that's why if we are able to, we look at this formula, and I say formula in terms of code, and we're able to get this to O of 1, then now you have, well, O of n. If we are able to optimize this to O of log n, then we're going to have n log n, right? So, yeah, so that's what we're going to do. So you can also, by the way, you can use a heap to keep track of the max, and that will give you a log n algorithm, for example, maybe sorted list if you don't want to use a heap, but that's one way to do it, and then, you know, you're sliding window in, and you're sliding window out. So that's going to give you an n log n solution. I'm not going to go over that one, but that'll probably be fast enough, I imagine so. But what I am going to do is talk about a linear solution, or a constant solution for the thing inside, and then O of n altogether. Let me think of how I want to do it. So the answer is going to be using a queue. The idea, and this is way, this is going to be the general idea for sliding windows, right? Because basically, you start with a queue, and here we use a deck because when we move the front and top. But now, yeah, and we want to look at the last case. So if length of q is greater than 0, we do, oh sorry, greater than k, oops, we pop left. And of course, you would only ever populate one number, so it's fine. Okay, what happens, right? What do we want to do? Basically, we want to get the max of the thing, right? So let's say so the new number that we're adding is going to be, the new number we're adding will be dp of I minus 1, because that's the new one. Actually, maybe we don't need to do that here. Maybe we'll do that after processing the best. So then now it makes more intuitive sense, maybe. Yeah, okay. And then maybe in this case, then we can keep the invariant here instead after we push the new number. Okay. And then so then here the invariant would be that q has k elements, or less than, right? At most, say. Okay, cool. So then now we just have to update it with best. And the way that we're going to do it, and let me kind of work out some math. This part I have to prove. I always have to prove a little bit in my head, right? So let's say we have, and these are on the DP values, by the way, not on the sequence. But let's just say we have a random sequence that looks like this, and we want to get the max of the last, say, 3 numbers. So then first, yeah, it's gonna be a monocube. I don't remember which way. I never remember which way. I just prove it to myself every time. But the idea is that, okay, so each element will have 2 items, right? One is the max inside, and then one is the current number. And then, so okay, in this case, I would build a 10, 10, right? And then the next would be a -5. And the question here for these kind of mono problems is kind of asking myself, okay, given that the current max is 10, can this -5 be a max? And the answer is yes, when the 10 gets left out, right? So then here, we will write down -5, -5. Right? Oh, maybe I don't need. Maybe I'm making it too complicated because I think there is. Oh, I think there is a one version where you always pop, and I think we need to keep that version. Is why. Okay, yeah, I think that makes sense. It's just that right now it's same logic for -2, -2. But then now let's say we have a 4, right? Yeah, and I think the Q version is. Yeah, I mean I think we need to change this a little bit, but I think we're fine. Yeah. Okay, we need to. Remove an element from I minus k, right? So yeah, so maybe the pop left as well. Yeah, okay. Then in that case, we don't need this double Q thing or double letter Q. It's just -5. And in that case, we don't need this. So yeah, so maybe the pop left as well. Yeah, okay. Then in that case, we don't need this double Q thing or double letter Q. It's just -5, right? And then -2. And then what happens when you see a 4, right? I guess this doesn't need to be tuple. When we see a 4, we go, okay, can 4 be the biggest number? Well, yes, but within this range, -2 can never be a possible biggest number anymore, right? So we remove it. -5 can never be a possible biggest number anymore, so we remove it. And then now we have 10 and 4. And then now we have a 0. What does that look like? That looks good because 0 can be the possible biggest number if these 2 numbers go away, right? And then the same thing with 3. When we insert the 3, we go, okay, 0 can no longer ever be the possible max number, so we remove it. Okay, and then now the max number will be the number in the beginning. So, okay. So then now all we have to do is replace best is equal to q dot, not pop left, just q dot 0 if length of q is greater than 0, right? So you don't do it for the first element, for example. We always will have at least one element because we start at 1 here. I was just trying to think about the case where we start at it's a pen, I think. That we start at the 0 element, but yeah. Okay. So then this will always have 0, at least 1 element. So then this is good. And then now we can do this. And then now we have afterwards we have to process. Also, if you got confused what I did here, I do have a tutorial on monocubes and how I derived this. So definitely check out that video. Remind me in the link below if I don't have it below, but yeah. So then now basically it's going to be monotonically decreasing Q. So then here, yeah, we add this, and then now we go. Now we're trying to insert, right? Well, this loop is also wrong, but yeah. So while Q dot, this loop is also wrong, but yeah. So while Q dot, well, the last element. Let's do while length is greater than 0, and the last element is if the last element is smaller than this element, then we got pop right, because we want to pop it from the right, and then we add it. Okay, and if it's equal, we don't want to pop it because we want to keep 2, right? Because we want to pop it. Then this element. Then we got pop right? Because we want to pop it from the right, and then we add it. Okay, and if it's equal, we don't want to pop it because we want to keep 2 instances of it for one reason. And then now we go, okay, if I is greater than equal to k, then we want to look at the element on num sub I minus k, and then we want to try to remove this element from the Q if it is the biggest element, right? So if Q of 0, let's say is equal to element, then we do a Q dot pop left, and that should be good. I lied because we forgot to insert the number, but mostly good, right? And I think this should be okay. Let's give it a spin. I guess I should just run it before saying that because I might not. Oh, it's just pop, not pop, right? Some of the naming inconsistency is a little bit awkward. Yeah, so that looks good now, and yeah, and this is gonna be linear time. So let's give it a spin. I might have a typo, who knows? But oh no, did I have a typo or do I mess it up? I think I messed it up. That's sad. Why do I have an off by 1? Basically, it's 100. Go to -1, -1, 100, right? So why am I getting this wrong? Also, you may notice that we actually don't need to keep track of stuff anymore. Oh, this is DP. Whoops. Oh, we actually don't need to keep track of stuff anymore. Oh, this is DP. Whoops. Okay. I because we don't want to remove the number. We don't want to remove the input number. We want to remove the last thing that we inserted k elements ago, which is this thing. So we do need it. Okay. Let's try it again with the submit. A little bit silly on off by ones. I think if I did it with a sorted list or something like that, this will be no. This is a silly mistake. I can make this mistake in sorted list anyway. So yeah. So that's basically the idea. The idea is DP with a mono queue, and of course this is going to be linear time. Why is this linear time? Given though there's 2 for loops, right? Well, this loop is going to be in linear number of iterations. Makes sense. And the queue, each element can only be added to the queue and removed to the queue once. So even though this is a while loop, this will only execute all of one time per element at most, because otherwise it just doesn't do anything. I guess I could just add this as a part of the end. But anyway, so yeah, so that's gonna be linear time in general. And then for space, this is gonna be linear space for both the DP and the queue. This is I can say this kind of a very hard one, especially if you do it in linear time and linear space. And log n is slightly easier, but still kind of tricky, because this idea actually comes into play a lot of tricky. To see it the first time, and of course I just have a typo, but which is fine. Maybe I could test more. Did I use sorted list last time? I thought you sorted list last time. Yep. Oh, Larry, you sorted list, and this time I removed the right one. Did I do it the first time as well? Yeah. Okay. So yeah, if you want to see that log n solution, check out the past. But today, I don't know what I figured, but today I wanted to do the linear time one. So hopefully that makes sense. Hopefully this is good. Some parts of the explanation is a little incomplete. The 2 things I would look up or just practice is dynamic programming, which is all this week, and then I have a video on monocube. What did I call it? Let me just find a link really quickly. Classic. So it's in my my channel thing list. It's called Larry Explains Monocube Part 1 and Part 2. Go check those out and then let me know what you think. That's pretty much all I have now though. So have a great weekend if you do contests. Good luck. I'll see you later. Stay good, stay healthy, good mental health. Take care and have a great weekend. Bye bye. Hey everybody, this is Larry. This is day 10 of the July Legal Day Challenge. Hit the like button.
Hello. Not interested. लक्ष्मी लक्ष्मी येणार होतीस ना तू नालंदामध्ये? येते ना? बरं, बरं. ठीक ठीक आहे, ठीक आहे, ठीक आहे. ओके.
For my sleepy problems, for my
Let me speak. Boxing. काय? पाठवू का आता? आधी आली.
आजी
उद्या गेलो. जरा जरा औषध घ्या. त्याच्यात नाही ठीक आहे. रात्री बटाणे भात खाणार आहेस तू?
और नाही ते भात ना पुलाव राईस ना तो ते माहित नाही चांगलं नाही लागलं.
चांगलं नाही झालेलं, खाऊन झालं.
खाल्लं मला एक घास तेव्हाच खाल्लं तर तो मसाला हे होता की काय काय ते होतं
इथे आणून त्याचं
माहित नाही. कमी नव्हता मला वाटतं जास्तच होतं की काय काहीतरी ऑफ होतं की काहीतरी वेगळं होतं ते नाही मी खाल्लं नाही.
इथं चांगलं मी ते म्हटलं very different than, you know, seeing the practice so much. कॉम्प्युटर समजा 2 वाजता फोन केलेला ती बोलते येते मी दुसऱ्या कामावर आहे काम करते नको येईल तर बघू येऊ बघू दे
इथे बसतोय वरती. तर काय हेवी आहे काय काढायचंय? अरे बा.
त्या पिशवीमध्ये लागलं बरं तिकडे लागलं.
When you have the
There are many new
70 मिनट।
हेलो एवरीवन, वेलकम टू माय चैनल कोड स्टोरी विद माइक। तो आज हम अपना डायनेमिक प्रोग्रामिंग के प्लेलिस्ट का वीडियो नंबर 60 करने जा रहे हैं और डीपी कंसेप्ट क्वेश्चन के प्लेलिस्ट को फॉलो कर सकते हो अगर आप बेसिक से और कोर से समझना चाहते हो डीपी को। उसमें रिकर्शन मेमोराइजेशन और बॉटम अप दोनों से मैं समझाता हूँ किसी भी प्रॉब्लम को, ठीक है। तो उसको फॉलो कर सकते हो उस वाले प्लेलिस्ट को। डिस्क्रिप्शन में लिंक मिल जाएगी उस प्लेलिस्ट की आपको। लीड कोड नंबर 403 है आज का। हार्ड मार्क्ड है बट बिल्कुल हार्ड नहीं है, बहुत सिंपल सा रिकर्शन और मेमोराइजेशन है इनफैक्ट। और मैंने देखा बहुत लोगों ने कमेंट भी किया है इस क्वेश्चन पे कि इसको एक्चुअली में मीडियम ही मार्क होना चाहिए। हार्ड ये है नहीं एक्चुअली, अगर क्वेश्चन समझने की देरी है और जो क्वेश्चन बोला बस वो कर दो, दैट्स इट, ठीक है। क्वेश्चन नाम है फ्रॉग जंप, समझते हैं अच्छे से क्वेश्चन को। गूगल में पूछा क्वेश्चन को। क्वेश्चन तो काफी सिंपल है, देखो अ फ्रॉग इज क्रॉसिंग अ रिवर। एक फ्रॉग है वो एक रिवर क्रॉस कर रहा है, ठीक है। द रिवर इज रनिंग टू सम नंबर, ठीक है, कैन क्रॉस द, यहाँ पर तो भाई आपको पता करना है वो क्रॉस कर, यहाँ पर कहीं पर एक स्टोन होगा जिसकी वैल्यू जो 17वें पोजीशन पर होगा, ठीक है। तो अगर वो उस पोजीशन पर पहुंच गया मतलब उसने रिवर क्रॉस कर ली है। तो भैया आपको पता करना है वो क्रॉस कर पाएगा कि नहीं। इनिशियली द फ्रॉग इज ऑन द फर्स्ट स्टोन एंड अज्यूम द फर्स्ट जंप मस्ट बी 1 यूनिट। देखो ये चीज़ ध्यान देना, ये चीज़ इन्होंने क्या बता दिया है कि फ्रॉग जो है ना फर्स्ट स्टोन पर खड़ा है और क्या है, ठीक है। मतलब इसका मतलब क्या हुआ, ये 0 लिया जंप, फर्स्ट यूनिट पर एक स्टोन है, ठीक है। यहाँ पर मैंने इंडेक्सिंग नहीं लिखी है, मैं बस बोल रहा हूँ कि तुम कहीं 0 पर खड़े हो, तुम यहाँ से एक जंप अगर लेते हो तो तुम फर्स्ट पोजीशन पर जो भी स्टोन है वहाँ चले जाओगे। तो फर्स्ट पोजीशन पे ये स्टोन है ही, जंप 1 का जंप मारा तो 1 का जंप मारा तो 2 आ जाएगा। देखो तो सेकंड पोजीशन वाला कोई भी स्टोन दिख रहा है, नहीं दिख रहा है ना, तो वो पानी पी कर जाएगा, तो इसको नहीं ले सकते हैं। अगर मान लेते फर्स्ट पर आप हो, इसको नहीं ले सकते। पोजीशन पर स्टोन है, यस है, स्टोन होना ऐसी बात है। अगर मान लेते हैं यहाँ 1 नहीं हुआ, ठीक है, अगर कहा कि पहला जंप इसका हमेशा 1 यूनिट का लेगा तो 1 यूनिट पर पहुंचेगा। अगर 1 यूनिट वाला स्टोन नहीं रहा तब तो पॉसिबल ही नहीं है, क्योंकि ठीक 1 हमेशा होगा और अगर नहीं हुआ तो रिटर्न फॉल्स कर देना उसी वक्त। क्या होगा देख लेना, कोई भी आगे वो बढ़ ही नहीं पाएगा, ठीक है। तो यहाँ पर 1 हमेशा होगा, देख लेना कोई भी इनपुट में 1 हमेशा होगा और अगर नहीं हुआ तो रिटर्न फॉल्स कर देना उसी वक्त, ठीक है। मतलब मैं ये बोल रहा हूँ कि स्टोन्स का ये कौन से पोजीशन पर है, फर्स्ट इंडेक्स है, ठीक है। तो चुपचाप रिटर्न फॉल्स कर सकते हो। फ्रॉग वो पर एक स्टोन है, ठीक है। चलो ये चेक तो डाल देंगे अपन। अब देखते हैं और क्या बोला है इसने। सिंपल का जो नेक्स्ट, मान के चलो कि अभी आप ना ऐसे मान के चलो, अच्छा इस डायग्राम को छोड़ दो, ठीक है, इस डायग्राम को छोड़ दो। मान के चलते हैं अभी आप स्टोन नंबर जो करंट जो स्टोन है, CS मतलब करंट स्टोन मान लो, है ना, करंट स्टोन मान लेते हैं। ये स्टोन नंबर 5 है, 5th वाला स्टोन है, ठीक है, 5th पोजीशन वाला स्टोन है। दो होता है ना कि करंट स्टोन से फ्रॉग जो है वो या तो PJ-1 जंप ले सकता है आगे के लिए तो अगर जहां पर तुम खड़े हो वहां से आगे के लिए तुम या तो 2 या तो 3 जंप from the current stone will be k minus 1, k or k plus 1. The frog can only jump in the तो ये कैसे यहाँ तक क्लियर है क्यों है जो भी लेंगी टोटल कितने स्टोन वो अभी यहाँ पर है तो देखो ध्यान देना यहाँ पर है तो इसका मतलब आप क्या फर्स्ट इंडेक्स ये फ्रॉग चला गया
9 rupees.
गया मैं यहाँ लिख देता हूँ फ्रॉग का करंट स्टोन क्या हो गया 1 हो गया भाई प्रीवियसली कितना जंप लिया था ये देखो प्रीवियसली इसने 1 यूनिट का जंप मारा था तभी तो यहाँ पर आया तो मैं लिख देता हूँ प्रीवियस यूनिट जंप